In this video, I'm going to show you how to do video segmentation and object tracking with SamGeo. This is a very powerful feature of SamGeo. It allows you to use just a simple text prompt, and you can segment all the frames in the video, and then you can save the mask. You can also combine them back as a video. So first, let me show you what it looks like. This is what we're going to do. We're going to segment a video of cars. And so all we need is just give the MP4 to the program, and then just type cars. You'll be able to segment all the cars for you. And it's also instant segmentation. That means not just cars, it can identify the unique ID of all the cars. And let me play this video so you see what we are trying to achieve here. It's not just for MP4. We can apply it to do remote sensing time series segmentation. So if you have time series images, we can use those to check the object moving. So it's very, very powerful, and it's very easy to use. I just integrate this into the SamGeo package yesterday, and it's going to make you a whole lot easier for you to utilize that. To follow this tutorial, you need to go to the SamGeo website, and then on the left side, click examples, scroll down to find video segmentation. So once you click this one, you can either run this one in Google Colab, or you can run it on your local computer if you already have that set up. I haven't tested this one on Google Colab yet, but it should work. This one requires the GPU compared to the previous one. They're just doing image segmentation. This one is video, so we have a lot of frames that you need to process, but you can try it out. So just change to T4 GPU and then uncomment this one to install the package. You also need to have access to the Hugging Face, the SamGeo video on Hugging Face. If you don't know that, check my previous video, and also the SamGeo image segmentation here. That you need to basically download the model from Hugging Face and then log in using a token. Then you should be able to use that. So I'm going to show that using my local computer here, and I'm going to show you step by step how to utilize that. You're welcome to use your own data, but I provide a sample MP4 that allows you to try it out and see how it works. Then you can do some customization with your own data. So first we need to import the library. Very simple. We just import SamGeo, the SamGeo 3 video. So this is a new class that I added to the package, and also we're going to download the sample data. To initialize the video projector, very simple, just SamGeo 3 video. Inside here, there are two parameters you can provide. The first one is the GPU to utilize, and the second one is the BPE path. And the second one, you can just use it at default. And this one does require the GPU. If you don't have GPU, it's going to be a little bit slow. So just run this one, and it's going to load, basically initialize the projector. It might take a couple of seconds, depends on your hardware configuration, but I can show you here on my Linux computer, and you can show the GPU utilization, right? So once it's starting, you will see, right, I have two GPU here, 16 GB each. And look at the first one, the second one. So GPU 0 and 1, right? So it has been loaded into the GPU, almost 5 GB. And the other one is also 4.2 GB. So it shows you that now we are on the GPU. The model is on the GPU. Once it's on the GPU, then we start doing the video segmentation. So to do that, first we need to download an MP4. And the functionality should work for an MP4 or a directory of images or directory of GeoTIFF. I will create another video to show you how to apply that to remote sensing time series images. But this video is just going to focus on MP4, or you can essentially provide a directory of JPEGs or PNGs. And so let's download this video here, and then all we need to just to click this one, set video. So basically we're telling the model to basically pointing to that video, and then we're going to process the video. So just run this one, and under the hood is going to convert the video into a bunch of JPEGs. So for this specific video, it's the 25 frames per second. So for each second, you have 25 images. And so in a total, we have 177. So roughly, it's around 5 to 6 seconds of videos. And so for all the images, it have been saved to the temporary directory here. If you want to see it, this is usually you don't have to worry about. It's just extract to the temporary directory, but if you want, you can certainly look at the directory if you want, right? So here we have all the images that have been extracted. If you can double click, you will see the video, so see all the images, and then you can just run through all the images. You can see it's basically just all the video basically is comes from a bunch of images. If you want to show the video in the Jupyter Notebook, you can. So here you can just call the same show video and then provide the video path. So here you can actually play the video. This one actually has some sound, but when we're doing the segmentation, the sound doesn't really matter, so it's going to remove the sound. But at least to show you, this is what it looks like. This is the video we're trying to do, and it's a SAM3, so it's a foundation model. It doesn't matter what video it is. Essentially, it's just going to identify the object, so it can do any video. Of course, the video, if it is large, then you might need a higher amount of GPU usage when you're processing the video. Okay, now that we have the video, what can we do? For example, I want to extract all the cars. That's simple. Just call this generate mask parameter, basically the function, then provide the text prompt. So the text prompt is just the cars, and that's it. So just run this one. It's going to basically start the section. So earlier we already load the model, and you will notice here the GPU usage is going to increase, and under the hood is going to process the 177 frames. All right, so you can see now my computer, the GPU is running and the fans are spinning, so you can see the loud noise if you're running this one on your local computer with the GPU. And so right now we're using roughly almost 10 gigabyte each. Right, so the first GPU 10 gigabyte, the second one is 9.2 gigabyte. So it does require some GPU. I think it's also depends on the capacity of the GPU. If it's smaller, you might not use that many. The SAM3 under the hood is actually doing all those things for you. But I have simplified the process so you don't have to do a lot of coding. If you go to the original SAM3 video example, it's a little bit complicated, a lot of lines, hundreds of lines code. Now I've simplified into just a couple lines code. So just create a model and then set the video and then generate the mask. That's it. Essentially just a couple lines code. Once you generate the mask, then we can actually see the result. So for this one, right now we're just using a text prompt, but later I'm showing how to customize it, because it might extract some object that you don't want, then you can remove them if you want to. All right, so it's done. It took 1 minute and 26 seconds. So it's around 86 seconds. You can think about roughly half a second per frame. So it's not bad, right? So basically just one image with half a second is actually pretty decent. If you have a better GPU, probably it should be faster. Once we have this, now we can visualize the results. So just call this show frame and then provide them the frame index. So we have from 0 to 176. We have a total of 177, right? So just run this one. It's going to show you the first frame. As you can see, it's pretty nice. It gives you a unique ID for each one. And so in total, we have 6 cards here in the first frame, right? 0, 1, 2, 3, 4, 5. And that's it. Also, you can see the size of the imagery, right? So this is roughly about over 700 rows, and also over 1,200 columns. So it's a decent size image, and under the hood is going to segment all the images, also give a unique ID to each one. So it's going to keep track of the ID for each one, give it the same color, and we can also show more frames. So here we have the show frames methods that give you a strike. Basically, you don't want to show 177 altogether. So basically for every 20 frames, you're going to show one. So frame 0, frame 20, 40, something like that. And you can specify how many columns do you want. Look at this. So we have 9 frames here in total for every 20 frames, right? And look at the result. Look very, very accurate, right? So the green car here is also all green. And the challenging thing about this kind of video segmentation is that the object is not always appearing on the same frame. So sometimes, for example, some cars might be driving away, and these cars will be disappearing after frame, for example, 40. But there are also some new cars coming on the road, and you can see it's not confused with the previous one. It's going to give them unique IDs, new IDs to imagery. So it's very, very powerful, and just a single prompt. You can imagine this one can be applied to anything in our daily life, any videos like video checking, sports, basketball, swimming, or anything. You will be able to keep track of those. And now you can play this one with your own data if you want to. So if imagine that this is the result that you get, but how about this? I want to keep track of every car except this green car. I don't want this green car. I just want to other cars. Can we do that? Yes. So there's a method called remove object, and all we need is just passing the unique ID, the object ID, right? So if you go back to the beginning here, we have this 6 cars, and I don't want this green one. It has the ID 2. You can remove it. So what we need to do is just call this remove object. And then once you remove the object, you need to propagate, because we have 177 frames, right? So propagate means you're going to process all the imagery, and this one is actually pretty fast. It doesn't need to process all the imagery, doesn't need to do all the detection, because just removing the mask. So this one takes less than 1 second, right? And now look at this, the black car number 2 has been removed. So we are not checking this object anymore. And this is very useful, because you might have a lot of objects. Sometimes let's say here, you only have one object you want to keep track, right? You can do the same thing, but I'm going to show you shortly how to keep track of the object. So you can add objects, you can remove object as needed. Next one, assume that this is the result you get, or you are missing some object, right? So if sometimes the result is not perfect, then you can add some prompts that ask it to add that object, right? And imagine if you just enter the car prompt, it doesn't detect the object you want, then we can specify a point prompt. So basically telling the program to looking into this object, edit it. And so for this one here, we're going to add back car number 2. So how do we do that? Then you need to find the coordinates of that car, right? If you go back to here, look at this one, go back to the original frame showing you the axis, so you can see basically the row and column number. So look at this number 2 car here, is the X and the Y axis. So roughly I think in the X axis around like 300, something like that, maybe 330, 320, right? And also with the Y, it will be around 200. So we can basically have a point, and then passing into the add point prompts here. And for this one, we are using 335 as X and 203. You can adjust a little bit as long as the point is within the object. You should be fine. And then we give a label 1. 1 means it's actually the one we want to detect. And you can also give more points. Right now, we're just giving 1 point. You can add more points if you want to. Imagine, for example, these 2 cars are all missing. Then you can have another point here. Also have to positive. Or we can say it to be negative. It should work as well. And also, this one is going to be giving to the object ID 2, and then we are going to basically telling it to process the first frame of this object 2, and then it's going to propagate. So this one does require reprocessing all the frames. You will see here, it's going to take a lot longer. So removing object is faster, because you have in the first round, we already detected all the objects, so just removing the unwanted object. But if the program is missing some object, then you need to redo that. So that one takes a little bit longer. But as you can see, right, roughly half a second per frame, so it's not too slow. Once we have this, I think it's going to be faster. Look at this, right, only 30 seconds. The first round when we did it took around 1 minute and 26 seconds. Now it's only like 40 seconds, so it's like half of the time. Once we finish the processing, we're going to show the first frame. Now you can see the car number 2 has been added, right? So you can see now we have this compared to the previous one that the car was like removed from the processing. So this is how we can use the text prompt to detect object, and also add some remove some object or add some new objects if you want to. The next one is even more interesting. So Sometimes if you're detecting an object, but you just want a portion of the object, not the entire object, can we do that? Yes. So we can, when you provide the prompt, we can provide multiple points, and we can provide a point positive and a point negative. You can provide as many points as you want. So look at this one here. Imagine that we want to keep track of car number 2, but we don't want the whole car. We just want to keep track of the windshield, right? So right now, if you just provide 1 point, it's going to basically guess that you want this entire object. But you can provide a point on the windshield, it's positive, and a point on the car front here is negative. Then it's going to remove the car, the front part of the car. So let's see how we're going to do that. It's the same thing here. We're going to provide a point here and another point. If you don't know the coordinates, you can go back to the first frame here, showing the coordinates. So roughly, for example, here will be roughly 300, and then maybe 210 for the windshield, and also maybe 200, 300, and maybe 210. Oh, this one is 190, for example, here for the windshield, and for the car front part maybe 210. So you just get those coordinates and then come back to here, specify the coordinates. Make sure that you give the label 0 and 1 and 0. 1 is positive, the one you want to keep track. 0 is you don't want them. And you can also specify the object ID, which one objects that these points belong to. So it's belong to object number 2, and also specify the frame index. And okay, we are going to apply this one to index. After that, let's do the propagation and see how it works. Again, this should be faster than the first round that you have to process all the frames. Although this one's still processing, but because it has the memory in the previous round, it should be much faster. So after the finish the processing, then we can see all the frames to see if it's correct or not. And you can certainly also remove all other objects. For example, these are all 0, the object that you don't want to. You can also remove them as needed. So almost there, 30-40 seconds. So in general, I think this one is 1/4 second per frame, so it's pretty fast. Okay, it's done, and it should be showing you all the images here. Look at this. Now we have the car here, and only the windshield is colored green. All the other, the front part has been gone. So that means we successfully remove the object. Look at this one, very clear here, right? Just windshield. So depends on object. So think about here is sometimes you might be just keep track of in sports events. You might want a certain body, or just want to keep track of the ball rather than the entire the player, and then you can do that, right? So if you have the basketball, right, the ball keep bouncing. Sometimes the basketball is attached to the hand. So when you're doing the detection, you might detect the whole object, but you can just keep track of just the specific part of the object that you want to. Once we finish the processing, we can save the result. So we have 177 frames. Under the hood is going to save all the frames as one imagery. So you're going to save all this to the mask. And so here, if you go back to the data, let me show you, open here, and the output. Okay, so look at this. I have all the masks, and these are all the JPEG, PNG. Like we have 177. If you're trying to open it, because it's ranging from 0 to, we only have 6, right? So because it's RGB integer 8, so 0 to 255, it's all very dark. You don't really see it, but if you open in other editing software, you will see those objects. So basically just the unique ID for each car. Also, you can save that, combine them as a video. So that means it's going to render the all the tiles, basically all the frames with the mask overlay on top. So basically going to combine all of these together as a single video or MP4. And this one takes a little bit longer because it's need to render all the frames and then do the audio overlay and then combine back as a video. So this one may take a couple minutes, depends on your hardware. And so I actually already generated previously. I can show you the result. This is the video that I showed you at the very beginning. It looks like this. So it's very cool. It's combining all the videos, all the images together, and then color name and also give a unique ID, and the ID also moving with the car. So it's super cool. And this is not possible in the past. You have to train the model to actually to be able to detect individual objects. And this is a foundation model. All it needs is a text prompt. And that's you can use it to keep track of, for example, airplanes, people moving, trucks, cars, or anything like that. Anything is moving, you can use to keep track, so that we can apply that to time series satellite imagery that we're going to show you in the next video. And once you I have 2 lines of I'm not sure why I have 2 lines here. This one actually is not needed. You can just remove this one. And then once you're done with the video, you can close the section. So close section, that means you can use it to do other prompting. And so basically just the first round, loading the model into the GPU and also spin up the section. So you just close the section, you can reuse it to open a new section. But if you're done with everything, then you can shut down everything. So if it's shut down, that means it's totally gone. Right now, this is still using the GPU here. If you look at my GPU, it's also roughly 12 gigabyte, and the other one is almost 10 gigabyte. Once it's done processing, you can close it. It's going to remove free some of the GPU resources, but not 100%, because the model is still stored in the GPU. But if you finish everything, then you can just do the shutdown. So let me show you. Once I do the close, okay, it's done. Then it's combined all together. So just run this one, and then it's closed. So if I open this one, it's still utilizing. So it's not freeing the resources. If I run this one, hopefully now the GPU will be released. So look at the second one. The GPU has been released. Interesting, the first one is still occupied. I don't know why. I might need to look at the source code, but at least you can see it frees some of the GPU so that you can. But if you restart the kernel, then it should be gone completely. So now I restart the kernel. Look at these 2 graphs here. Drop to almost 0. That means now we have released all the GPU resources to the program. Okay, so that's all I want to show you. As you can see, it's very easy to use. You can replace this one with your own video, your own images. It can be a bunch of images you can use to keep track of anything. So, and then just use a text prompt. You can remove, add objects. You can also customize the multiple points so that you can remove unwanted objects from the segmentation mask, and the result can be saved as PNG, JPEG, or combined as a video. Okay, try it out and let me know in the comments what kind of application you want to see, or what you want, how it works. In the next video, I'm going to show you how to do time series segmentation for remote sensing imagery. Okay, that's all for this video. See you in the next one.